so Mr. Douglas Crockford, he's a senior JavaScript analyst, architect at Yahoo, and he has an interesting history, and I'm sure you all have met, actually, his software, I mean, his codes in some form or other, probably every day. And so Doug was born in Minnesota, but he decided it was too cold over there and left at a young age. And he votes and owns a car. So those are good things. He holds a degree in radio and television from San Francisco State University, and he held roles in his past such as Director of Technology at Lucasfilm, Director of New Media at Paramount, and you are wondering what he's doing in computing at this point in time, right? Because those are very interesting jobs in themselves. Well, he decided to change direction, and his career took him in the direction of software, and he served as the CEO of electriccommunities.com, and he was an inventor of the language called Tilton, which he claims is the ugliest programming language that was not specifically designed to be ugly programming language. So that's an interesting thing. But he later founded and served as CTO of State Software, where he discovered JSON data interchange format. And as he worked in learning systems and small business systems, office automation, games, interactive music, multimedia, location-based entertainment, social systems, and programming languages. But really what he is best known is his involvement with the JavaScript. And he's now the senior JavaScript architect at Yahoo, and he's a regular speaker at a variety of events. And he serves as ECMA script on the ECMA script committee. So please help me welcome to the podium Mr. Douglas Crockford.
Good evening, each and every one of you. So you see JavaScript in the title. This isn't really a talk about JavaScript, although there will be some JavaScript in it. So if you're squeamish about that, you might want to leave now and give your seat to someone more deserving. Mainly we're going to be talking about programming style, which is something which crosses all programming languages, and your brain. And some might be wondering, well, what could my brain possibly have to do with computer programming? I hope to show you an unexpected and exciting discovery which actually links these two in an important way. So much of the science that I'm going to talk about tonight is from this book, The Science of Fear by Daniel Gardner, which is a very accessible introduction to some amazing research in psychology and economics, looking at how people actually think. And it turns out that we have two systems in our brain which could be characterized as the head and the gut. The head is the thing which can be taught arithmetic and mathematics and logic. It's the place where we do our reasoning. And it's something which may be unique to humans. And then there's the gut. The gut sort of evolved from the flight or fight response. It's very, very fast, but it can get things wrong. And that's okay, because in coming up with that response, being fast is more important than being right. The interesting thing in this research is how those two systems are related. It turns out that the gut informs the head and provides part of the working set that the head uses in doing its processing. And the surprising feature is that we're not aware of the gut providing the initial set to us. And because the gut is designed to be fast, it often gets things wrong. But that still becomes part of the assumptions that the head uses. And as you know, if you have any logical system in which you have false premises, you can get incorrect results. And that's something that we do. The researchers who were uncovering this stuff were quite surprised to find that they were not the first to have figured this out. Who was there before them? The advertising industry, turns out, knows a lot about how we think, more than we thought we knew about how we think. And because they can sell to the gut, And it turns out if you can sell to the gut, it doesn't matter if you're right, it doesn't matter if the product helps you or hurts you. You can convince people to do things that are not in their own interest if you can convince their guts. And that's a lot easier than convincing the head. And no industry understands this better than the tobacco industry. You look at tobacco, what does tobacco do? It makes you smell bad, does that immediately, turns your teeth yellow, eventually it'll make you sick, and then it will kill you. So how do you sell a product like that to people? You don't sell it to the head. You sell it to the gut. You sell it to the system which doesn't understand arithmetic and doesn't understand the long term, the system that is most easily confused. There are some things about tobacco usage which could be explained by nicotine addiction, but there are lots of aspects about it which aren't. For example, brand loyalty. That most smokers will use the same brand every day until it kills them. You know, that's selling to the gut. I mean, that's an important thing, and they're really, really good at that. So if you ask a smoker, why do you smoke? A why is an analytical question, so that question gets addressed to the head. So the head will answer, but the head will first be informed by the gut, which will tell them, oh, first off, it's not dangerous. You just go, okay. If it weren't for that, if you ask someone why you smoke, they go, I smoke. Well, that's stupid, I should stop. But that's not what smokers do. And they'll start to rationalize, or it appears to be rationalizing. And if you push really hard, they might even appear to be lying, but they're not. They're just reasoning from an incorrect premise. So they'll start coming up with reasons for why they do what they do. You know, like, well, I do it for flavor. I have to have the taste of burning weeds in my mouth 20 times a day. That's how I relax. Or it makes me popular. They can think, yeah, smoking makes me popular, ignoring the fact that everybody else in the restaurant, all the healthy, good-smelling people, are trying to get away from you because they don't want your stink to taint their food. So the influence of the gut is so compelling that it will force us to ignore experiential evidence. It's ranked higher in priority than that. So what's this have to do with computer programs? Well, it turns out computer programs are another thing that we do with our brain. And computer programs are the most complicated things that humans make. You can look at all of the systems that we produce. Nothing is more complicated than computer programs. And they're hard, because of that complexity, they're hard to make. And it was recognized early on that we needed a better way of writing programs. And so it was thought, well, let's let the computers write their own programs. If we can make the computers smart, then we can just tell them what we want them to do, and they will figure out the programming necessary in order for them to do what we need them to do. And you could even do that through a couple of generations. So at some point, we could ask the program, make a program that's just like you, except better. And do that a couple of times until they become intelligent, and then they become our overlords. That was sort of the theory behind artificial intelligence. And it didn't work. Artificial intelligence has been able to do some amazing things, like play chess and even play a decent game of Jeopardy. But you cannot give a set of specifications and a pile of user interviews to a program and have it write a program that implements that. We just don't know how to do that. And so as a result, we're still writing programs pretty much the way we always did, by hand. So the most important tool that we've developed for doing programming is the programming language. And we've developed, I don't know how many of these, probably thousands, maybe hundreds of thousands of them by now. It is our principal tool for doing programming. The original programs were a list of numbered instructions which would fetch data out of cells and put data into cells. That was way too hard. And so with each generation of programming languages, we up the level of abstraction to give us more leverage in doing our work. But still, it's work. And we're constrained by how much we're able to accomplish. One of the things that makes programming so difficult is that it requires perfection. The program has to be perfect in every detail, in every aspect, for all possible inputs, including inputs that we cannot anticipate. And if it fails to be perfect in all those dimensions, then the computer has license to do the worst possible thing at the worst possible time, and it is not the computer's fault, it is the programmer's fault. So understanding the compelling need for perfection, you would think we'd be much more careful in the way we put software together, but we're not. If we held on to software until it was perfect before we released it, we would never release software. And so instead, we do the opposite. We release it as soon as possible, even when we know it is not imperfect, and just kind of hope to get away with it. It's not a good way to be doing things, but so far it's the best we have figured out. So it's kind of amazing that we can do programming at all. If you look at where we came from and who we are hunters and gatherers. And I don't mean that metaphorically. There's been no human evolution since the Neopaleolithic era. So we have the same bodies, the same brains as those guys had. And there was nothing in their experience running around in the Ice Age looking for stuff to eat, which suggests that we should be able to program computers. There's just no reason we ought to be able to do that. And yet, somehow, we do. You know, how is that possible? I think it's because of the unexpected coordination between the head and the gut. The head is obviously of paramount importance in doing programming because you need to keep so much state and so much model in your head in order to effectively program it. But that doesn't explain how we do it, because if you carefully observe what's happening when we're programming, at some points we're doing top-down analysis, sometimes we're doing bottom-up, sometimes we're in and out, sometimes out and in. We're constantly changing our focus in ways which you cannot describe. You cannot put together a formula which describes all the steps that you have to do to break down a program and convert it into something that runs. It's sort of magical. And so I think it happens because of the gut, that the gut somehow, as a participant in this process, helps us to find those leaps of insight which make programming possible. If it were not for the gut, programming could not be done. Now, I have no evidence at all to support that statement. But my gut tells me it's true, so I believe it. So this brings us to JavaScript. Heard of JavaScript, anybody? Just a few hands. So JavaScript is the world's most misunderstood programming language. Has nothing to do with Java. It's actually, it turns out it's a better language than Java, but this is still not widely known. I might be wrong about that. So JavaScript was invented by Brendan Eich at Netscape Corporation in 1995. He designed and implemented this language in 10 days, which is an insanely short amount of time to design and implement a programming language, but he did. And as you might expect, spending only 10 days at it, he got a lot wrong, because this was definitely a rush job. And his employer did not test the language to see if it actually worked in real applications before subjecting the world with it. So not unexpectedly, it has a lot of bad parts. It was unfinished. It's tragically broken in a lot of serious ways. The surprise is that it has good parts. In fact, it has some of the best parts ever put into a programming language. It has functions as first-class objects, which was an idea taken from Scheme. Basically, lambdas, if you've heard of lambdas, they're in JavaScript. JavaScript is the first language to take lambdas to the mainstream. That's an amazing accomplishment. It also has an object model that was derived from a language called Self, which was the next step in the evolution of Smalltalk. So there's still some people who think that JavaScript is not an object-oriented language. It's actually a more highly evolved object-oriented language, having eliminated the need for classes. It turns out classes are an unnecessary concept, baggage, which not necessary, and you're better off without it. JavaScript is such a language. So you've got some of the best ideas in the history of programming languages and some of the worst ideas in the history of programming languages in one language. And so there are good reasons to use this language, but there are also big hazards that come with it. So in order to make it easier to deal with JavaScript and its defects, in order to constrain myself to using just the good parts, I developed a language or a program called JSLint, which is written in JavaScript, which reads JavaScript programs and which finds all of the uses of forms which are bad parts. So if you're using anything which isn't good parts, it tells you. So using JSLint, you can write significantly better JavaScript programs. And the program comes with this warning. JSLint will hurt your feelings. And it's true. I've seen people cry, because JSLint, said things about their programs, and they write to me and say, it hurt my feelings. Can you make it stop doing that? And I always write back, fix your code. It's not that hard. So why does it make people cry? It's a program which helps you to improve your program, make it more perfect. Because perfection is ultimately the goal. We want our programs to be perfect. So this is providing advice. You must have wanted the advice if you ran the program. So why does it upset you that it's helping you, that it's doing exactly what you intended it to do? That's a really interesting question. And I started looking more deeply into that. And I find the gut. I think the gut's involved here. So here's one of the fundamental problems of programming style. Do you put the curly brace on the left or the right? When Ken Thompson designed the B language, he put them on the right. There's not a good reason to do it one way or the other, but he decided to do it that way. And his partner, Dennis Ritchie, who then designed the C language, made the same choice. But there are guys in their lab who said, no, we don't want to put them on the right, we want to put them on the left. And there was not a good reason for it, and I'm sure they debated for a couple hours. They said, oh, this is stupid. Leave us out of this. Put them on the left, just stop talking to us. So it's sort of a shame, because since then, we still don't know which way to do it. It's sort of like driving cars. There's not a good reason for us to drive on the left or on the right, but there's a good reason for us to all be on the same side. This doesn't require the same level of consistency, but it's similar. I was in India last month, and I said this too, and it didn't go over nearly as well. I don't know why that is. So one thing you can get people to agree on is you should be consistent. You should always put them on the left, or you should always put them on the right, because it looks stupid to sometimes mix them up. That doesn't make any sense. And you can get anybody to agree that everybody should do it the way they do it, because that makes sense. But, on the right, anybody who puts their curly braces on the right? Okay, who puts them on the left? Yeah, there's no good reason for either way. So we're stuck. We just don't know how to do it. In fact, if you take someone who grew up putting them on the left and have them go to work for a shop that's putting them on the right, and you say, first day of work, and by the way, you've got to put all your curly braces on the right from now on, they'll start to cry. And you go, why are they crying? I mean, it should be an obvious thing. It's just punctuation. Put it this way or that way. What difference does it make? So ultimately, I don't know what the right answer is, but I do know for JavaScript, you should always put them on the right and never on the left. And here's why. So in JavaScript, we have a return statement, and we have object literals. And a very common thing you want to do in JavaScript is return a new object. And so this is the way you write it. And if you put the curly brace on the right, it does exactly the right thing. And if you put the curly brace on the left, it does a terribly wrong thing. And it does it without any notification. There's no development time warning. There's no runtime warning. It's just that your program, instead of returning a new object, returns the undefined value. So the failure will not occur at this point in your program, but some future point in the program where debugging is much more difficult. And even if you do manage to find out what caused it, you're going to come back to this statement, and you're going to stare at it for hours, and you're not going to see what went wrong. What went wrong is there's a design error in JavaScript. There are a number of rules which interacted in an unexpected way and caused this to misbehave in a way which is not reported. And it's tragically terrible. So you should always put them on the right, because if you always put them on the right, this error will never happen to you. If you put them on the left, it will. Once I had someone come up to me and say, boy, that made so much sense. So every time I write a return statement like that, I'm going to put it on the right, but all the rest of the time I'm going to put it on the left. You're just asking for it. So there's a principle you can extract from that, which is prefer forms that are error resistant. If you can do it one way and it sometimes fails horribly, and you do it the other way and it never fails, this shouldn't be hard. This should be a really easy trade-off. It costs nothing, big benefit, that's a win. JavaScript has a switch statement, which was inherited from C's switch statement, which was inherited from B's switch statement, which unfortunately was inherited from the Fortran computed goto statement. We now know that goto is harmful, but this particularly nasty form of goto has found its way into all modern programming languages. And the hazard is that you can have a case, or by default, all cases will fall through into the next case. One day someone wrote me, well, in the early days of JSLint, and said, you know, you really should report on this because this is a particularly nasty error and it's very easy to happen and it's very hard to find it in reading the code. That's a good thing for you, for a code quality tool to give a warning on. And I said, yeah, I guess that's true, but you know, sometimes you can get your cases to all line up, you know, so that everything does fall through and it's really elegant and, you know, that's a really nice thing. And I have seen the other error, but this elegance is just so nice. So on balance, I think, you know, the bad thing hardly ever happens and the good thing is just so good. So I think I won't do that. Okay, so next day, the same guy writes to me and says, hey, I found a bug in JSLint. Oh, good. So I throw it in the debugger. Yeah, everybody knows where this is going. I had a case that was falling through. And in that moment, I achieved enlightenment. You know, we imagine we spend most of our time, you know, typing in our programs. I'm typing my program. But it's not. We spend most of our time staring at the screen saying, my God, what have I done? You know, how am I going to take this puddle of confusion and turn it into something that works? And somehow we block it out. So we spend most of our time making mistakes and then searching through and correcting our mistakes. We spend a very, very tiny fraction of our time programming. But, so we black out on that stuff. We forget about all the mistakes we make. I couldn't this time because it was so obvious and so humiliating. I had just given this speech and you know, in my own code was the argument for why I was completely wrong. So how did I get to be so wrong? It was this statement. I said, that hardly ever happens, which is how the gut says it happens. The gut is terrible at math. The gut thinks that a lot is worth more than all. The gut thinks that not much and nothing are the same. It can't do math. It's wrong. And I had the gut telling me what my answer should be about switch. I shouldn't listen to my gut on matters of style, because it's wrong. So a good style can help produce better programs. Style should not be about personal expression or personal preference. It's much more important than that. It should be about approaching perfection. That's a completely different thing and requires much more discipline. You know, all of these things are going to be trade-offs. You know, so trade off the cost of doing something versus the negatives of it and all of that. The benefits, it's a hard analysis to do. And I've heard a lot of people make the trade-off, well, I like that, so that's how I want to do it, so that's a good trade-off. That turns out to be a lousy analysis. So there's some things we can learn from the literary world. So the Romans wrote Latin all in uppercase with no word breaks or punctuation. Apparently they were able to read this stuff, and they're okay. Even though there's an ambiguity in the third line, you could read it as now or DB reeks. You know. So you really have to, you know, it takes a lot of work to parse this stuff and figure it out. But it worked for the Romans up until Constantine established Christianity as the state language of the Roman Empire. At that point, it became necessary to make copies of the Bible and the other sacred texts and distribute them all across the world. And they didn't have originals for any of these documents. They had copies of copies of copies. And when, in comparing them, they realized that none of them agreed. So nobody really knew what the sacred text said. So, and they knew that as they made more copies, this was only going to get worse. So medieval copyists introduced lowercase, word breaks, and punctuation. These innovations helped reduce the error rate because it made the text easier to see, easier to read, easier to understand, therefore easier to copy. And these innovations turned out to work. I mean, they were refined over a few centuries. Gutenberg adopted them into printing. We still use them. And there's a good reason for why we use them. They make our language much easier to understand. So the use of good style can help reduce the occurrence of errors. It works in human language and can also work in computer programs. An example of a style guide for English is The Elements of Style by Strunk. There are lots of other style guides too. I like Strunk a lot. His stuff's a little dated now. Turns out language is a dynamic thing which has evolved since he wrote his book. But it's still a good book, and there's still a lot of good advice in it. So programs must communicate clearly with people. That's why style is so important. Some people think that it only matters that the program communicate its instructions to the computer, but that's almost the least important thing that it does. Particularly as our techniques become more agile, it's critical that we be able to read our own code and understand what's happening. In some cases, you think, well, it's not important for the code to be good because I'm the only person who's ever going to use it. But I find that doesn't even work. That future me looks at that code and goes, I don't know, who's the idiot who wrote this? This doesn't make sense. I need help. So writing the code clearly so that it can be read is of critical importance. So use elements of good composition where applicable. For example, in writing in English, we'll use a space before a comma. We won't put the space after the comma or move the comma to the left margin. We don't do goofy stuff like that. We have conventions for how we use punctuation. And if you depart from those, people can still make sense out of the text, but you don't want them to be spending their effort trying to figure out where your hyphens and commas were supposed to be. You want them to be thinking about what your code does. And most of the rules that we use in English apply directly to computer programs. But there are a lot of places that don't, because computer programs have to be much more precise. There have been several attempts at trying to make programming languages look like English. And there would be lots of good reasons to do that if it worked. But it turns out we need a level of precision in programming that we don't need in communicating with each other, mainly because the computers aren't nearly as smart as we are. So we need to be more concise. So we have a problem in programming languages where some characters, like the parentheses, are overloaded. Sometimes they're used for grouping, sometimes they're used for invocation. We can use spacing to help make it clear which of those we're doing. And in some cases, people ought to be able to figure it out. But again, you shouldn't have to have them struggling to figure out what your program does. That should be clear from the structure of the presentation. Let's skip that one. Okay, so JavaScript has a with statement, which was intended to be a helpful thing for programmers, a shorthand for doing object manipulation, but it doesn't work right. So here we have with O, foo equals coda. It's going to expand to mean one of these four statements. Can anyone guess which one? I'm not surprised. It's a trick question. It could do any of them. There's no way you can tell from reading the code which one it's going to do. And in fact, every time that statement executes, it could do a different one. It could mean something different every time it runs. So how can you have any confidence in the correctness of the program if you cannot read it and understand what it says? It turns out you do not need the with statement. You can simply not use it and just write the thing it expands to instead, and the program works just fine. And in fact, it's much better. So my advice is don't use the with statement. Now, some people say, well, that's not fair, because I can do really clever things with the with statement. And I agree, you can do very clever things, but I cannot tell if it's being used correctly. So the problem, I'm not saying it's not useful. I'm saying there's never a case where it isn't confusing. And confusion is the enemy, because we're trying to achieve perfection. And you cannot be perfect if you're confused. So confusion must be avoided. So don't use with. JavaScript has a double equal operator that does type coercion. That turns out to be a really bad thing, because if you're coercing values as you're comparing them, you'll get false positives. And so you see some really surprising examples here. Fortunately, JavaScript has a triple equal operator, which always does the right thing. It doesn't do type coercion, so it'll give you false for all of these cases, which is right. You've got one operator that's sometimes problematic. You've got another one that works right. Use the one that works right. Never use the one that does the wrong thing. Now, I've had people say, well, sometimes that double equal actually accidentally does exactly what I want. But the problem is the people reading your code don't know that. They don't know, is he using double equal here because it's the right thing in this one case, which is pretty rare, but it could happen, or is he just incompetent? There's no way to know. So you don't want to force that kind of decision making on your reader. You want them to be confident that, in fact, you are competent. So if there's a feature in the language that is sometimes problematic, and if it can be replaced with another feature that is more reliable, use the reliable feature. Here's a new thing that's in JavaScript. You see this in a lot of other languages, multi-line string literals. By the way, does anybody know why they're called strings? Nobody knows. Nobody knows why we call these text form strings.
Strings of characters.
It could be strings of pearls. Why are they called strings? They don't look anything like strings. Earliest reference I found is in the Algol 60 report, but there's still no explanation as to why they called them strings. Anyway, I don't like the multi-line string literal for a couple of reasons. One is it breaks indentation. And indentation is really important because we have deeply nested stuff. And if suddenly things have to get slammed against the left margin, it breaks the readability of the program. It's harder to track what's going on where. But even bigger is this problem with the syntax error. So the first statement is correct. The second one is an error. Can anyone spot the error? Yeah, there's a space right here. See it? It's obvious once it's pointed out. But you want to have programs which are obviously correct. You don't want programs to be indistinguishable from programs that are incorrect. So avoid forms that are difficult to distinguish from common errors. Here's another one. We've got if A equals B, then do some stuff. What that statement means is assign B to A and then test A. What was probably meant was if A and B are equal, then do the stuff. So if we see the statement in white, we have to assume, does he know what he's doing, or did he make a really common error? You know, which did he really intend? All we know for sure is that the programmer is incompetent. So you know, if you meant to assign B to A, then write that. Make it clear. You shouldn't force the reader to guess. Because if the reader has to guess, then there's a very strong likelihood that bugs will be introduced in the next revision. We have scope, which is a really powerful idea in programming languages, goes back at least as far as Algol 60, which controls the visibility and life expectancy of variables. Most modern programming languages have block scope. So any variables declared inside of a set of curly braces are visible only inside those curly braces. JavaScript doesn't have that. It has function scope, which means a variable declared anywhere within a function is visible everywhere within the function, but not outside of the function. Now, it turns out function scope is all you need. You can write excellent programs having only function scope. But JavaScript syntax looks exactly like the syntax of languages that have block scope. And so programmers coming to JavaScript from other languages get confused by that, and confusion is a bad thing. So where you see this is in the var statement. The var statement does a thing called hoisting, where it gets split into two parts, and the first part, the declaration, gets moved to the top of the function. If you're not aware that this is going on, then your programs will misbehave, and bad things can happen. So my advice is to be aware of that and program the correct way for the language. So for JavaScript, that means declare all of your variables at the top of the function, declare all your functions before you call them. It's not required that you do this, only if you want your programs to read consistent with what they do. Now, in a program that, in a language that has block scope, often the advice is declare your variable in the deepest block where it makes sense. But that is the worst possible advice in a language that doesn't have block scope. So make your programs look like what they do. The place where I see people have the most trouble with this concept is with the for I statement. They really want to declare the induction variable in the for statement, which is actually an error in this language because the variable is not scoped to the loop. It's scoped to the function. And if you declare any functions inside of that loop, they will capture the induction variable at the wrong time. So you'll capture generally their completed state and not the current state, which is a bug, and it's a bug that's very difficult to find. So like in all the other cases, you should declare the var at the top of the function. And people cry about that. I don't want to do that. But it's just good advice. Your programs are more likely to work correctly more of the time. So write in the language you're writing in. You know, they'll say, well, in Java, that's the right way to do it. And they say, well, you're not writing in Java, are you? You're writing in JavaScript. And that turns out to be the wrong way to write in this language. Let's skip that one. So here's the most controversial one, plus plus. This was added to B and found its way into C and all the other languages in order to increment a pointer. Now, it turns out that pointer arithmetic is considered harmful. So none of the modern languages are doing that anymore, except for C++. Everyone else went away from that, but we still have plus plus. Plus plus was implicated in the operating system buffer overrun security phase of the 90s. It has big security problems. One of the reasons is that we are compelled, when we're using this operator, to try to optimize for putting as much stuff into one line as possible. I find that's true for me. If I'm using plus plus, I'm trying to squeeze it all in there, get as compact and tiny and overloaded as possible, which is stupid. But I cannot resist. When I start using plus plus, I cannot stop myself from doing that. So I don't permit myself to use it anymore, ever, in any case. I always use the slightly longer form, x plus equals 1, which will add 1 to variable x. It takes one more character, but it's well worth it. And somehow I'm able to control my compulsions if I write it this way. Now, I've had some people say, well, I should be allowed to use, you know, x plus plus, because it means exactly the same thing, and it saves one character. Like that's, I mean, one character, that's meaningless. I go, okay, but actually it's not, because it's actually equivalent to x or to plus plus x. So when I see someone using x plus plus interchangeable with plus equal 1, I have to figure, okay, this guy doesn't know the difference between pre-increment and post-increment. That means for every plus plus in his program, I have to look at it really carefully and figure out, has he just introduced an off by 1 error or not? Because it's really easy to do that transposition and get it wrong. But if you write plus equal 1, that error never happens. And it's nice to be able to point to an error and say, it never happens. Recently I found this. I was reviewing some code and I saw plus plus x plus plus x. So it might be that he meant x plus equals 2. And if he had written x plus equal 1, that would have been a much easier modification to make the program only change one character. Or maybe it's a copy and paste error. I don't know. I don't know. So, you know, I don't like to see code like that. So for no cost, by adopting a more rigorous style, many classes of errors can be automatically avoided. The global variables are evil. Let's just leave it at that. OK, so here's another example. We've got a statement var a equals b equals 0. Some people think what it means is create variables a and b and set them both to 0. But what it actually does is it sets the global variable b to 0 and then sets a to whatever that is, which is wrong. So again, we've got an ambiguity here. This is a statement that appears to be doing one thing is actually doing another thing. So we don't want to be ambiguous. We want to be clear. So write in a way that clearly communicates your intent. Here's another example. We test A, and depending on its value, we'll call B and C. What it does is, or what people would expect is, it will call both B and C, but it doesn't. What it actually does is it calls B and then unconditionally calls C. I think this was a major mistake in B and C and every language since then, except for Python, that the brackets should have been required. So every time you write an if statement, for statement, while statement, do statement, always have the curly braces because they cost virtually nothing and they eliminate this confusion. So it's much less likely that someone's going to come in afterwards and turn this into an incorrect program if you always type in the curly braces. And I've had people complain, oh, I don't want to do that. You have to go oh, so hard. It's easy. It's 2 characters. You know, slow me down. You know? We don't spend our time typing. That's not where the time goes. It's looking into the abyss. That's where the time goes. And if you put the curly braces in on every if statement, you're going to spend less time looking into the pit. So as our processes become more agile, our coding must be more resilient. And adding your curly braces will help your code resist that sort of problem. So programming is the most complicated thing that humans do. And computer programs must be perfect. And humans are not good at perfect. And again, it's a miracle that we can do this at all. And for people, you know, anybody here not a programmer? No, just a couple. You must be pretty shocked at what we're doing. You know, you never thought, my God, is that what they do? Is that how they think? Yeah, it's outrageous, isn't it? But yeah, is this how we think? Is it? Yeah. So, you know, obviously we're not good at perfect, but we want to be as good as we can be. So designing a programming style demands discipline. It's not selecting features because they are liked or pretty or familiar or popular. It's because they help reduce your error rate. Ultimately, that's the only thing that matters. So the JSLint style was driven by the need to automatically detect errors. When I started JSLint, I had no idea where the program was going. It taught me a lot about JavaScript. It taught me a lot about programming, things that I was not smart enough to figure out on my own. JSLint taught me these things. So, you know, in looking at forms like the with statement, I tried to figure out, can I automatically determine if this thing is being used correctly or not? Because there are obviously many cases where it's used incorrectly. And I could not. I could not come up with tests which would determine if it was used right or not. So then I would have to go back and look at my code and see where I was using it and go, my God, I'm an idiot. You know, so the part where JSLint hurts your feelings, I know it's true. Because after I put in a new rule, I'll then run all my old code through it. And it slaps me the same way it slaps you. And you know, over the years, I've learned to trust it and always to do what it says, because it's smarter about JavaScript than I am. So yeah, forms that can hide defects are considered defective, even if you can arbitrarily come up with a use of it which appears to be correct. In general, I just can't be confident of that. So there will be bugs. I'm not suggesting at all that we can eliminate bugs, that we'll ever achieve perfection. What I'm talking about tonight is moving the odds in our favor. If we can reduce the error rate for no cost, that's a good trade-off. So the approach I'm taking is language subsetting. Only a madman would use all of C++. Some would say only a madman would use C++. I'm not going to argue that tonight. But there are features in every programming language that are bad. A programming language designer does not have the power to remove his mistakes. Once an error gets into a design and the design gets released to the net, it's locked and you can't change it. It's really hard to impossible to remove mistakes. So there are mistakes in languages. You have that power. You can remove the mistakes by simply not using them. By constraining yourself to using just the good parts of the language, you get a better language. It costs nothing to do that. When I was a journeyman programmer, I would study the manuals. I'd pull it open and I would learn every feature that was in the language, and I would endeavor to use every one of those features in every program that I wrote. And I don't think it was to show off how smart I was, because nobody knew or cared. It was just something that I felt compelled to do. I now know that that was stupid behavior. That what I want to do instead is try to write programs that are as clear and simple as possible. And that is not consistent with trying to make maximal use of the wrong features. So finally, this is it. This is the end. Good style is good for your gut. Thank you, and good night. Anybody? Yes.
What do you think about the JavaScript compilers that they're pushing out now, like Google, to take all your JavaScript and shove it into one unreadable block of code?
So what do I think of the JavaScript compilers that take all of your code and munch them into one unreadable block of code? For delivery of programs on the web, I think it's a good idea, because it turns out the biggest cost to the user of using a web application is the time it takes for the JavaScript to get delivered to the browser. So anything we can do to reduce that time gives the user a better experience. So the process you described helps us in a couple of ways. One is it reduces the number of TCP interactions because we're trying to move everything as one unit. Minification will reduce the size of the program, so fewer packets to move the thing over. It can be gzipped, which could reduce it another factor of 2 maybe, and it could also be cached, which means that the second time you go through, nothing happens, and so that's doing nothing is always a lot faster than doing something. Where it's potentially bad is if the thing that's trying to do the compression is too aggressive. It can interfere with good programming practices, and it can even, in the worst and stupidest cases, introduce bugs. In that case, stop, because life is too short to be using programming tools that introduce bugs. We just cannot tolerate that. Some minifiers are less ambitious, and so will not introduce bugs, and that turns out to be a good thing. So in general, I like that stuff. Anybody? Yes?
Do you think building new languages on top of JavaScript, like CoffeeScript, is an appropriate way to avoid the bad parts of JavaScript?
So do I think building new languages on top of JavaScript, such as CoffeeScript, is a good way to get around JavaScript's problems? Yes and no. I like CoffeeScript a lot. I think it's a very elegant language. I wish JavaScript looked more like CoffeeScript, and that may actually happen. So future editions of JavaScript may actually start to more closely resemble CoffeeScript. I do not recommend CoffeeScript in production because, first off, it's not a stable language, and so the programs you write today might not compile through CoffeeScript in the future. You just don't know. And it makes debugging a whole lot harder because the code you have to debug is not the code that you wrote. And any time you're doing that, it makes it difficult. But I like the experiment, and I'm very pleased with some of the early things CoffeeScript has demonstrated. Although I have to tell you, CoffeeScript has bad parts. There are some things I think it's gone a little too far and put in some features that some people thought might be fun or clever, which turn out to work against the goals we've been talking about. And I've seen people trying to use every feature that's in CoffeeScript in order to show off how good they're at CoffeeScript. All of that stuff is counterproductive. Anybody else? Yes?
That JSLint program you mentioned, does it pass its own scan?
It does. There have been times it didn't, and I heard about it. But yes, so one of the tests of JSLint now is it must always pass itself, and it does very consistently now. Yes?
I have two-part questions. What's your opinion about JavaScript using on the server side? Yahoo have any initiative in that direction?
Okay, so what's my opinion of JavaScript on the server side, and what's Yahoo doing with that?
Does Yahoo have any initiative in that direction?
Okay, so first off, JavaScript was one of the first server-side programming languages. Netscape had a product in 1996 that did server-side JavaScript. Unfortunately, it failed. So we don't have to contend with any of that legacy. So that's a very nice thing. There's a more recent development, for example, Node.js, which is being developed at Joyent, which takes the event loop model that the browser uses and takes that and puts it on the server. And I think that is brilliant. At Yahoo, we've got YUI 3 now running on Node.js, which means that we can now have our YUI applications run identically on both ends of the network without any rewriting, without any duplicated work. So that means that we have a lot of options now. So if it's a full Ajax application, we do everything on the browser. If we're going to a stupid browser like IE6, we can say, oh, we'll just run everything on the server. We have that option now. We don't have to rewrite in order to accomplish that. Or if we have an application that has a huge amount of JavaScript, takes a long time to load, we can do the first page view in the server, send that out as HTML, so the user's got something to look at while we then send all the JavaScript. So we've got the best of both. Again, we don't have to rewrite any code in order to accomplish that. That's brilliant. We haven't announced how we do our stuff in-house, but we're very seriously looking at this architecture because it makes a lot of sense. Anybody else? Yeah.
How do you think that Node.js type of programming language will change the future of JavaScript?
Will Node.js change the future of JavaScript? Probably not. JavaScript's first mission will always be to be the programming language of the browser. It has a unique role there that no other language can fulfill. And so there are a lot of demands on JavaScript to move in a lot of different directions, but first and foremost, it has to remain the language that it was intended to be. Despite that, we're looking at other things that we can do to the language. One of the most important things that I hope will be in the next edition will be a module system. So it'll allow you to have a compilation unit and declare an interface around that compilation unit so that we're not exchanging global variables anymore, which is a recklessly dangerous thing. But instead, we can have good software engineering practices which would allow for code from multiple parties to be able to run cooperatively in the same context, which is important. I mean, that's the mashup idea. JavaScript, remarkably, was the first language to get mashups working well. But unfortunately, its security model wasn't adequate. So, when we add modules in the next edition, then I think we'll be there. There will be other things, some things that you've already seen in other languages, like in CoffeeScript and lots of other stuff. At this point, I can't predict what's going to be in the next edition because we have about that many features under consideration, and I don't think we can put more than about that many features in an edition. So it's not clear to me how that's going to shake out. But watch the skies and the mailing lists. Okay, we have time for one more. Yes.
As HTML4 has changed, I think, to be better to work with in JavaScript, do you see a coevolution model between JavaScript and HTML?
Do I see a coevolution model between JavaScript and HTML? I wish. Okay, so HTML and CSS belong to the W3C, and ECMAScript, JavaScript belongs to ECMA. And in the history of those two organizations, they've had one meeting, which was not a successful meeting, and we've not had a follow-up. And we keep calling out to W3C, this stuff's important. We need to synchronize these things. They don't see the need for why we need a meeting. So I suggested to ECMA, tell you what, let's take over the web standards and we'll do it. We'll have a turf war and we'll make them work. And they go, no, we don't really want a turf war. So okay. The browser is a horrible programming model. It's quite awful. And some people think that JavaScript is a terrible language because of that. It turns out that's W3C's fault. That's not JavaScript's fault. JavaScript's just a programming language. The programming language standard says nothing about the DOM, says nothing about the browser. It's just a programming language, and it's a good programming language. The DOM is this hateful API that is provided by W3C. It's how you're forced to interact with it, and it's one of the worst APIs in the world. Not only is it horrible to work with, and it's badly specified, and it's not portable, and it's buggy, and all of those things are wrong with it, and inefficient and all that, it's also hopelessly insecure. And So we're fixing the security of JavaScript, which is great, but if we don't also fix the security of the DOM, it's a waste of time. So I would very much like to be working with W3C to fix this, but they're not answering our calls, so I don't know. But thank you very much for that. That's it. So thank you and good night.